cover the current. Now the next thing is how you're going to get the voltage higher. Okay, so the voltage essentially is determined by the, if you ever learned the physical organic chemistry, you possibly know the molecular orbital theory. So we're talking about the HOMO, highly occupied molecular orbital, lowest unoccupied molecular orbital. So essentially, the voltage is determined by the HOMO level difference between the donor and the acceptor. Okay, so just take my words on there. So what you possibly want to do is by changing the structure unit, you will be able to lower the HOMO and increase the difference between the LOMO and the HOMO from the donor and the acceptor. Remember here that you're talking about two different moieties, two different components in the system, because in the organic solar cells, the functional mechanism still same thing as almost the same thing as inorganic. So in the inorganics, you are using p junction. You possibly heard about that, right? P junction. So in the organics, you're using organic p junction. Okay, so you rely on the polymer, which is being the p-type semiconductor, and you have a buckyball, which is n-type semiconductor. The problem with buckyball is that it's not absorbing enough light. So now all the jobs fall on the polymer side. So you want the polymer to be able to absorb enough light, which I said you need a low band gap. And you also want a polymer to be with a low HOMO energy level, because the lower the HOMO, the bigger the gap, the higher the VOC, right? We call the voltage, open circuit voltage. So that brings up another challenge, that how you're going to bring the HOMO down that will give you a high voltage. So we did that too.